Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay and is ready to get their brain charged up, get their brain stimulated. I'm here to do that. So let's go ahead and get started. Today we're going to discuss a vector in the fourth quadrant. In my last three lectures, if you've been following me, I've discussed vector in quadrant 1, quadrant 2, quadrant 3, and today we're going to close this section by examining vector in quadrant 4. So this is my x-axis, this right here is my y-axis, okay? And then what we're going to do is we're going to draw a vector in fourth quadrant right here. And we're going to call this vector D, and the magnitude of this vector is going to be 4. How's that? All right? Now the angle is always measured from x-axis. So angle from here to here is 90, from here to here is 180, here to here is 270, and here to here is 300 degrees. Okay, that's given. Now what we want to do is we want to find the horizontal component and the vertical component of this. It could be a force, it could be a velocity, it could be acceleration going in this direction. All right, so let's go ahead and do that. So dx, okay, the horizontal component, basically the shadow of this vector on x-axis, that is what I'm looking at, this force right here, is going to be 4 times cosine of 300 degrees. Dx is equal to 4 times cosine of 300 is 0.5. So basically you get 2. All right. We find the y component, dy, which is equal to 4 times sine of 300. And then 4 times sine of 300 is negative 0.866. If you solve that, you get negative 3.46. All right, so we have found the horizontal and vertical component of this vector going in this direction. So dx is equal to 2 meter, dy is equal to negative 3.46 meter, and this makes sense. If you look in here, this vector is going this way. The horizontal component is going to be positive because when you have a vector going this way, this is the way horizontal component is going to go. Dy makes sense because your force, your acceleration, your velocity is going in this direction. Your y component is going to be this way. Okay, so that is the reason we have this minus sign. Make sense? All right, just wanted to give you a quick tip that I have an old calculator. All right, when I punch in, go into my calculator and type in cosine 300, it gives me a weird number. All right, so keep in mind that what we have to do is, newer calculator are fine. Okay, the older calculator, what you have to do is you have to convert the degrees. These are the 300 degrees, convert that into radians. Okay, if you need to brush up on radians, I do have a lesson under calculus collection, so feel free to surf through that. So that is going to be basically 5 pi over 3. 5 times 180 is 900. 900 divided by 3 is 300 degrees. Now if you want to convert that into a decimal value, what you have to do is you have to 5 times 3.14, which is the value of pi, 22 over 7. That's the ratio of a circumference and diameter. This ratio will never change. No matter how big your circle is, how small your circle is, the ratio of a circumference over diameter is going to stay same. So then I have 5 times 3.14 over 3, and I get 5.235. So when I do cosine of this in my calculator, I get 0.5. All right, I just wanted to mention that real quick. Hope you enjoyed it. I'll see you in the next lecture. If you like what I'm saying, please share it as much as you can and give me a like. Take care of yourself. Till next time.